I've been talking in all the previous videos about how we're going to use Excel to find the slope and the intercept and r squared. Well, that's what we're going to do now. So we have some data here, and if we take a look at this data, we can see that we have monthly sales data, some sort of product, thousands of dollars of sales, and we also have some ad spending. What we'll do now is we're going to look at a linear trend. We're going to use time as the predictor for sales. The first thing I'm going to have us do is we're just going to copy all of this data. We're going to copy it over to another sheet. There we go. The reason why is for linear trend, we don't care about ad spending, so we're just going to delete it so we don't have to deal with it. There's other more elegant ways, perhaps, of doing a comparison when you don't have contiguous data, but this is the simplest way. Let's take a look here. If I were to just look at this data, it looks like it could be having a trend. So let's go and put in a chart. I'm just going to put in a real simple chart. Yeah, it looks like it's going up over time, but there's a little bit of bounciness to that data set. It's worth investigating further. Now, I'm going to get rid of this for now because we're going to do something first. Let's take a look. If we expand here and we look at what is July 1st, 2018, what is that in terms of time? If you convert that to a number, you get this weird looking number here. What's that? Well, that is how many days it's been since January 1st, 1900. All right, that's a long time ago, and any company that you're likely to work for, especially one in the Bay Area, doesn't have data that goes back to the turn of the last century. So it probably makes sense if we're only going to work with relatively recent data, is to reset our axes. So just to show you, here's what it thinks 2 is. It thinks 2 is January 2nd, 1900. All right, we don't want to be working with that kind of data. So what we're going to do is we're going to say, let's just work with a month since June 2018. So we've got monthly data now. And we're working with numbers that are a little bit friendlier to work with. Now, what we're going to do is we're going to capture all of the sales and all of the months that we have sales for. And we're going to insert a scatter chart. And it has to be a scatter chart because what we're going to do now is we're going to do something with this scatter chart here. Okay. And it looked like the line chart, except there's obviously no lines. But we're going to now add a chart element in, and we're going to add a trend line in. And while we are going to work with linear forecasts, we're going to go to more trend line options. And we're going to allow ourselves to display both the equation and the r squared value on the chart. All right. Now, it puts it down in the middle of our stuff that's going on, which is kind of annoying, but that's just Excel for you. And it makes it really small, so you have to go and adjust this. And now let's take a look at what this is. And I'm going to move this over even just a little bit further, so I'm not covering up any data points. And we can see that we have indeed a linear trend going up. And what the model is saying is that around June 2018, the model would have predicted we'd sold under 7,000 of this product, and every month thereafter we seem to have a growth of roughly about $360. Let's actually, while we're at it here, let's go given month, And it's always nice to say, what time period 1 or 0 is. So June 2018 is month 0, just so you have some context there. Let's take a look at the r-squared. The r-squared is 0.55, so that's saying just a little over half the variation in sales is explained by time increasing, which it's an okay predictor. It's not great, but we'll consider it. It's not awful. So we might say, what are we going to do next? Well, we're interested in predicting what we're going to be selling in month 15. These are just text labels. We could copy everything in here, but there's a better way to do this. So what I'm going to do is I'm going to type in here, I'm going to type intercept, I'm going to type slope, and r square, and correlation. And then what I'm going to do is I'm actually going to make use of the intercept function. So with the intercept function, what it says is give me the known y's. The y's are what we're trying to forecast, and match those to the things we're using to predict, in which case this is month. And notice we get 6.86, much like we got here. All right, slope, going to be similar. I'm going to do slope. It's going to ask, hey, what are our known y's? There they are. And what are we using to predict those, in this case, sales? And it shouldn't surprise you that we get the same thing here. R squared is a little less to type. The order on the others did matter. We're trying to predict sales given time, not time given sales. But the r squared doesn't really matter whether you put x or y's first. We have indeed 0.55. And the correlation. Is like so. And it shouldn't surprise you that if we look at the correlation is the r squared with a square root, right? That's where we go. All right, now what we can do now is we can say, well, what are we going to sell in time period 15 according to our predictor? Well, we have the intercept plus the slope times the time period. And that's the date format. Date format is very pervasive in Excel. Once you have something with a date format anywhere, it likes to just spread it all over. It's kind of like COVID. All right, let's take a look. And what this is telling us is that the model is predicting that we're going to sell just over 12,000. But before we say, oh, well, boss, that's what we're going to do, we are going to use the next video to look at something else.